Alright everyone, let's get started. This is going to be tough. Everyone? Mason, sit. I don't know how much time I have on this video because it's not through Zoom, because the internet is not working, because TDSB is like that sometimes. Okay? Please consider this. Yeah, if you don't have a sheet, come grab one. It's on this pile right here, 5.3. From your grade 11 class, even in grade 10, in grade 10, you looked at 3 different transformations. You looked at A, D and C, or H and K. You learned transformations of a parabola using horizontal and vertical shift, as well as a vertical stretch. In grade 11, you learned one more thing called a horizontal compression or stretch factor. As a review, I want to apply this onto our sinusoidal curves as a review of how you can transform sine curves the same way you would transform any other parent function, f of x. So in f of x, this is what happens. In sinusoidal functions, this is what's sort of happening. We are going to go through it using the typical step-by-step method that you might have learned in grade 11. And then, after we try some, and you recognize how messy it can get, because the curve repeats again and again and again, I want to introduce you to another method. I just simply call it the box method, in hopes that you can see how simple it is to draw a sine curve, and if it's up your alley, then you can adopt it and make it your own. Starting off, here are the colors I'm going to use for vertical stretch, horizontal compression, and shifts. Okay, so translation factor, shift factor, it's the same thing. A, anything that's related to A, I'm going to use the color green. You can just follow along. Anything related to K, I'm going to refer to it using the color blue. And then D and C, it's not as important for now, because you typically do D and C at the same time, right? So there it is. If you are graphing it in the step-by-step method, well, this is what we're going to do, right? Vertical stretch factor, if you have an A value, you're gonna, what? Multiply all the Y values with an A. For K, it's a horizontal compression factor, so you're going to be multiplying all the X values with 1 over K. Now, this is a review. If this is unfamiliar to you, just wait until I get to the instruction portion, okay? D and C, if you are quote-unquote subtracting a value from X, we are moving to the right. And if you're adding a value to the entire function, you're moving upwards. And the opposite is also true. It might be a bit of a mouthful just to read and memorize that, so we're going to see how that looks in practice. Step-by-step method, I gave a random function. Step 1, you need to make this curve or this equation look exactly like this format, which means we need to factor out that K value. You need to divide a half out of this entire thing. So Y is now going to equal factor out the half. What's left inside? Well, half divided by half would be just 1, but what about that other number? Zach? Close. The other way. Yeah, you're dividing by a half. It's like you're multiplying by a 2. It's pi over 2. Alright. So I can highlight that, but again, so there's your A. There's your K. Here's my D. And here's my C. If A is, so this is what you would do for step by step, right? You would go from left to right. You want to do the stretch and compression factors, and then you want to do the shifts later. And so here it is. The first 2 boxes, when you're doing a sinusoidal function, right? The first value is not just the horizontal compression. We know that this is going to be the amplitude. The k value, again, this is a bit of a review, is going to change my period. It used to be 2 pi for a full cycle, but if I compress it, clearly 2 pi is going to be smushed and we can finish one curvature before 2 pi arrives. So this part, you can say it will change the period. Changes period, or you can just say it becomes a, it affects and turns it into a new period. This is going to be same shift. It's going to be called a phase shift. And this is just a vertical shift, right? So let's see how that plays out. The first two things that we need to watch out for are going to be the amplitude. It's the -3. The second two, very important. It's going to involve the k value. And that's the hardest parts of graphing an equation. And then D and C is, whatever colors you chose for that. These are very simple. So as you can see, in the normal method, you have to really, really watch out for the stretches. If you mess up the stretches, well, it sort of sucks. Oh, shoot, I colored it in pink. That's supposed to be yellow. Now it looks orange. Anyways. Let's move on. If the a value happens to be a negative, what do we do to the function? There's a reflection on the x-axis. Reflect on x-axis. In case you forgot, I am flipping it like that. I'm flipping it. Up, down, down, up. Rotating it this way. And the amplitude, that is what I'm multiplying everything by. So the amplitude, if it's a -3, I'm multiplying 1 by a 3, and I'm multiplying the -1 by a 3 because I'm already reflecting. So we have a vertical stretch factor of just a, right? Of the absolute value.
Sorry, what does the -3 affect?
Pardon?
Which part the affects 1/2?
Say that. Ask again.
-3.
Uh-huh.
What does it affect?
It will remember the sine curve used to be just 1 and then -1?
Yeah.
Well, I'm multiplying everything by a 3, so it goes up now and down, right?
So it goes up to 3.
It goes up to 3 and down to -3, and then you have to flip it. So instead of going up to +3, you now go down to a -3, and then you're going up to a +3.
Yeah, it's more like in a better to phrase it. The negative, you multiply the x and y values of the course.
You're going to multiply just the y
Just the y
values.
values.
Just the y values, yes. K. If the k is negative, it affects the x values. It reflects on the y-axis. In other words, I rotate it like that. This way. Okay? If the k value is a negative, I'm rotating it on the y-axis. And because it also does a compression, I'm going to write horizontal compression. You're multiplying all the x values by 1/k. an absolute value, of course, because we already dealt with the negative portion. And then I'll do short form. Phase shift of D is just the horizontal shift by D units. So it could be left or right. Vertical shift up down by C units. This is what you learn even from grade 10. And again, I'm expecting you to come in with some level of understanding of transformations. We didn't really touch much on chapter 1, transformations there, because, well, for the sake of time. But you get an exposure here. So my goal is to show you this grade 11 method in hopes that you see that it is effective, but it's also rather messy. And then we'll get to the box method. Yes?
I just have one question.
Pardon me?
I have one question. Because the amplitude is like with vertical stretch factor A, so like for example, a regular sine would just be 1 from minus 1 goes up. Like it would go up to 1, then down to minus 1, up to 1, now with minus 3 in front, you go up to 1.
Yep, you'll see.
But
You'll see.
I'm not confused. What does the G value then do? Like with the vertical shift?
Shifted the entire thing up.
Oh, okay. So
Yeah.
the amplitude is adjusted, like for the Y value.
It's a multiplication. It's a stretch factor. It's a multiplication.
And then that just brings it up.
Well, take a look. Rewriting, our curve had an A value of -3, the K was half, D was a positive pi over 2, and C was a -1. As a reminder, because I'm going to draw using colors, again, even with all these snazzy colors, you will see that my chart gets really, really messy. Here we go. My original parent function is a sine curve. So what do you know about a sine curve? It's going to be starting at 0. It goes as high as a 1, and then back to 0, and then -1, and back to 0. So because this is gonna change, I'm just gonna remind myself of where the original function was. Like that. And of course, you know that I can reproduce that on the left side, but that's not important to me right now. Or maybe I should do it. You know that it's going to be here, and then here, and it just continues. Right? So on and so forth. For the sake of time, how about we apply each color at the same time? I am going to multiply every value by 3 and then reflect it. Or would you rather I reflect and then multiply it by a 3? Do you care? No, choose for me. Doesn't matter. Okay, well, you know what? Then I'll make the decision. Let's reflect it first, because on our sheet it says to reflect first. 0. Reflect it. 0. Times 3. Yeah, that doesn't change. 1. Reflect it. -1. -1 times 3. -3. 0. Reflect it. 0. Times 3. 0. -1 becomes a +1, and then +1 times 3. Draw with your 5 dots the best curvature you got. Go ahead, please.
I know you're gonna push this. There's an individual distraction.
Next. Again, people who know what they're doing, it should sort of come naturally by now because you don't have to wait for me. You know where I'm going. The k value is half. In other words, I am multiplying the x values by 1 over k. Let me do a little calculation here. The k value equals 1 over 2. All my x values are going to be multiplied by 1 over k. In other words, this is going to be x times 1 over 1 over 2, which is the same as x times 2. Long story short, this is not a horizontal compression. I'm actually horizontally stretching it by a factor of 2. I'm multiplying everything by 2. That's what this means. So let's do it. 0 times 2. 0. Pi over 2 times 2. Pi. Pi times 2. 2 pi. And then 3 pi over 2 times 2, it's going to be 3 pi. It's going to be somewhere way over there. Okay. Let's go the other side. Negative pi over 2 times 2. Negative pi. And negative pi times 2. Negative 2 pi. Connect those blue dots. Let me zoom out. So which makes sense? The sinusoidal curve, the function, used to be a period of 2 pi. Now, one wavelength, one period is double that. Before, a full cycle completed in 2 pi. Now, look at the blue. The one cycle completes in 2 pi. Oh, sorry, 4 pi. Before, the period, the green, right? It used to be 2 pi. One cycle fit in 2 pi. Now, look at the blue. One cycle fits in 4 pi. Because of my horizontal stretch factor of 2. It's stretched horizontally. It's doubled. So what used to fit in 2 pi, now I need double the space, or double the rotation. I need 4 pi. Yes?
So let's say we have a point here. It's what is the original function? The 10 one?
The original is at this dotted line, right?
So we have a point of pi over 2, 1. Okay?
Correct.
When you put it into that new function, multiply pi over 2, which is the x value,
Yes?
by 1 over 2. By
Well, yes, pi over 2 is now multiplied by a 2, actually.
by 2, not 1.
Well, the k value is multiplied by 1 over 2. Sorry, the k value is 1 over 2.
Yeah.
So the x value is in the equation, the k value is going to be 1 over 2. Therefore, every single x value is going to be halved. Right? In other words, it takes the x value twice as long to reach this value of 1, this height of 1. It's hard to describe on just an image. I'd have to show you by a chart for you to understand why, if it says half, I'm actually multiplying it by a reciprocal, multiplying by a 2.
I remember one of them is either the stretch or the x, the A or the K is the one that
Well,
flips like.
Come see me outside of class and I can explain to you why that makes sense. It's a very simple example, but I don't have time for it right now.
So multiply by 2.
Yes.
Basically flip it. If we have 1/3, multiply by 3.
Yes. Yes.
And the 1 we multiply by -3.
1,
The y value.
the y values are multiplied by -3, correct. So this is the only one where reciprocal comes into play.
Okay, so the k basically flips.
Yes. The k value is half, and how does that affect the graph? You're multiplying it by the reciprocal. You might want to write that down somewhere. Alright, from there, from the blue, I'm actually going to do this at the same time. That blue curve is going to shift to the right by pi over 2, and I'm going to go down by -1. So pi over 2 is basically 2 squares and 1 down. 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 Then 2 squares and 1 down. It's going to be over there. So if I were to connect the dots, it would look something like... Wait, is it 2 squares?
Yeah.
Yes, which means my answer key, I did something wrong. Stupid me. Can't really see that, so I'm going to go over it. There. I made a mistake in my answer key. It's so pretty. You can kiss it. But like, I only went across 1 accidentally. Anyways. Again, remember, the goal of this exercise was to show that although it's effective, it can get a little bit messy. Would you agree? Just a little bit? So I'm hoping that you'll be really, really taken by my box method and use it because it's so much faster in my opinion. Yes?
The method that my teacher taught in class too was like he made a chart, and the chart had like a value, and then like all of the, it was the values that affected the y. He added, so like if the y was being multiplied by 3,
Yep. Yep.
y plus 2, and then
It's-
you just rounded it up.
It's x divided by k plus d, and then ay plus c. No, it's true. It's used, like it's the same thing, but sometimes I think there's more memorization for that and less room for thinking. And if I give you one of those Ferris wheel word questions, sometimes it can get really annoying. And so I want to show you this way instead. Transversal axis. Let's talk about this. What is a transversal? What is the midline of this yellow curve? Yep. -1. Interesting. There's coincidence? Okay. Anyways, period. No. Double. 4 pi. Right? And by formula, you can actually calculate this. The new period is actually equal to the old period divided by k. Let me explain. The old period is 2 pi, and if I divide by k, it's the same as saying 2 pi times 2, it's 4 pi. That formula you can take with you. Right? And as you can see, there is a relationship between the new pi and the new period and the old period through k. I want you to see that there is a relationship and we don't necessarily have to multiply all the x values to find it. Okay? Here's my hint. Amplitude. What is my amplitude?
-3.
How do you know?
Because amplitudes are A values.
Yes, but I want you to do this. The amplitude is going to be just 3. Okay? So there is a relationship, and this isn't, this one isn't a mystery. Okay? For the amplitude, you can go straight to the A value and you know how much it is. Max and min.
So why is it not -2 and -4?
Hmm?
Why is it not -3 and -3?
Well, what's the difference? From the middle, if I go down by 3 and I go up by 3, at some point you'll see a negative, some point you'll see a positive.
Oh, okay.
So amplitude by definition is how far am I moving from the middle?
Oh, so we don't care about the sign.
We don't care. Absolutely. So maximum is these two together, right? From the middle, I can add 2, or from the middle, I can subtract 2. So it's going to be a max of 2 or a minimum of -4. Huh. Interesting. Could it be that there is a relationship and we can figure out and use to our advantage? Seeing as how there is a coincidental relationship between the actual letters and what I draw? The answer is yes. If you know your A, K, D, and C, you can actually draw out the midline. You can draw out the max and min. You can draw out where we start and how large the period is. In essence, what you're drawing is the maximum, the minimum, the start, and the finish. You're going to create a box using dotted lines, and you're going to stick one cycle inside it. That's my box method. Let me explain by doing this. Okay, so this. Let's pretend you didn't understand my box method. You don't get it and it's just too confusing. Can you do this on your own? Bottom line. I hope so. Practice it, practice it. Here's another one, and I believe my answer key should be correct. You can take a look at that one and compare it with your work later on. I want to show you the box method so that we can use it and see if you like it. Yes, Yusuf?
Max and min.
Mm-hmm.
We use the C value and minus from the amplitude.
Correct.
Get the max and min.
Correct.
So you have -3.
It's this.
It's okay.
The middle line plus the amplitude or middle line minus the amplitude.
Oh.
Alright, box method. Same as before, I am going to rearrange this so that it shows me exactly what AKDC is. And I'm going to write that down. A equals -3. K half. D pi over 2. And C -1. You're going to see that my colors are all over the place, so I'm not going to confuse you with that. What I'm going to do is actually map out using logic. And the reason why the box method works only for sinusoidal curves is because it keeps on repeating. So think about it. If I can sketch one cycle, that's supposed to be a box on the video. If I can sketch one cycle of this curve, I can argue that I'll take that one cycle and I'll copy it and paste it forever. So if I can figure out one picture, I figured out the entire curve. With me so far? Does that make sense? Take a look at this. This is how much I've shifted. In other words, that is where my transversal axis, my mid-axis is going to be. So whatever color you use for this, draw a dotted line at -1. Next, I know that I am going to go above and below that middle line by a value of 3. So from -1, count 3 up, which is going to be a max of 2 and a min of -4. Already, so far, does that make sense to you? From the middle, I'm going to have a cap, or I'm going to just call this the roof. And I'm going to call that the floor. You already know my max and min. So far, so good? So what's next when I draw a box? My start and where I finish. Where am I starting? Well, there's a shift. Normally, a sine curve should start at 0, 0, right? But I shifted. So using pink, for me, my box is going to start at pi over 2. And where do I end? Not 2 pi. And this is what you have to calculate. New period is old over 1 over 2, which is 4 pi. So wherever you started, your pink, count out 4 pi and draw your ending line, which is about 2 boxes to the right of that entire graph. Do you see the box?
Yes.
Pink, green, green, and blue. Your goal is to fit one curve inside that box.
Do we start from that intersection between yellow and
Exactly. So sine curve begins in the middle of my box. And because it goes up and down, where does sine curve end? At the middle of the box. And because it's a sine curve, there's another middle right in between. So count your squares if you want to. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 boxes.
It would be like, yeah, like 2.
So 1, 2, 3, 4, 5, 6, 7, 8 is another midpoint on the yellow line. Are you starting to see a curve?
Yes.
Kinda? Can you explain how you got the blue line? Well, using that formula, I know that the old period is 2 pi. But because of a horizontal stretch factor, it is now 4 pi. So if my curve starts here, it must finish after 4 pi worth. Yeah. Okay, so I'll write this. Okay? And normally a sine curve would go up to maximum and then down to minimum. However, be careful, there was a vertical reflection. So instead of going up, you go down. So this is 8 boxes, 8 squares. I'm going to count 4. 1, 2, 3, 4. And at that point, I should touch the bottom green line. From the center of the curve, I'm going to count 4 boxes. 1, 2, 3, 4. Directly in between the last 2 dots. And then that point right there should have a accuracy point at the roof of this box. With these 5 dots, can you draw a rough sketch of a curve? I hope so. Isn't that sort of neat and satisfying?
Yes.
Right? I like it. When I first learned this, it wasn't through my teacher, it was actually through my elder sister. And it blew my mind. And I never looked back. Transforming the original step-by-step method took me like, I was fast with my graphs, okay? And it took me like a good 2-3 minutes. But doing this, I could...
Say like 10 minutes. That's it.
No, right? But this, just knowing what AKDC is, I could do it a lot faster. It was so simple for me. So I could actually focus on the question as opposed to wasting time on a graph. But that's me. Now, a lot of the tests that we get will say things like, show all intermediate steps. I'm going to say, don't worry about it. If you know what the graph looks like, without a graphing calculator, because obviously none of you are allowed to have a graphing calculator, that's fine. Yes?
If we were to do this on a test,
Mm-hmm.
would we have to show the lines or...
Yes, I need to know that you're still thinking, that you're not just like cheating your way through or whatever. Or if you're using the chart method where you're multiplying with A and whatever, at least show me the graph. Show me your
I
work.
think we did that more with on
Yes.
side, so we did it with like right.
Mm-hmm. Mm-hmm. Like, is that a question?
Yeah.
Yep.
This only works for like this line.
Correct. Only for repetitive curves, sinusoidal.
So you have to do the other ones for
Unfortunately, yes. The step-by-step works for all functions, but because this is repetitive, there's a special way to do it. Huh? No, I mean regular polynomial functions and other parent functions, like the square root function.
No, I mean like sine.
Don't worry about tan. When we're graphing, it's just going to be sine and cosine. Now, take a look. We're going to try it again.
But this does work for cosine.
Absolutely. And we're going to try that right now. Yes?
So, even though we're reflecting and shifting and stuff, we're still using similar characteristics to,
Well, it's going to be exactly the same. Take a look at this.
like, because the sine function starts at the midpoint, that's why we know it starts at the midpoint.
Yes, correct. Take a look at this. Okay, this curve, and that was what we drew for the previous. Do you see the yellow line?
No, I understand that. I'm not.
I know. I just wanted to show the class, right? That yellow line with this one, it's the same curve. You choose whichever way you want. I'm going to show you the box method one more time because it's new, and I'm going to do it on normal speed.
I just meant if we're drawing a sine curve, we still use the similar characteristics from a sine
Correct.
curve.
You'll see me do that here. Everyone, this example is a little different because the k value is negative. So think about where my finishing blue line would be. So I draw my yellow, I draw my green, I draw my pink.
We on this side?
The blue line, yes, exactly. I draw on the other side. And you'll see me do this, okay? Here we go. We have A, 2.5, K, -1, because I need to factor this out. My D is pi over 4, and my C is -1.5. And for the sake of the video, I will use colors once again. Oh, my highlighters are starting to dry out on me. Rip. Okay. And also off on the side, the new period is equal to the old period divided by a 1 over k, which is a -1. My new period doesn't change, it's just on the other side. Right? Nothing changes. So let's do it. So I'm going sort of in reverse. The coloring is a little different. I start with the midline, and then I draw the max and min, and then I draw the start and finish. Midline, 1.5. That's a 1, that's a 2, that's a 3, negative 1, negative 2, negative 3. Negative 1.5. Max and min. Plus 2.5, minus 2.5. Everyone, I'm half done. Ain't that nice? That's how fast this is. Starting, pi over 4. And my finish is 2 pi, but remember, it's not 2 pi on this side. We got to flip it over. It is 2 pi on this side. Okay, so remember, the pink is my start, and blue is my finish. Don't be tempted to start here. If this was a sine curve, don't be tempted to start here and do that. You have to start here and finish at the blue, right? Remember what your start line and your finish line is. So over here, I have a cosine. What do you know about the starting point of a cosine?
It starts on pi over 2.
At the highest point. It starts right here in the top of the corner of the box, and then I go down and then I come back up. So where do I finish? At the same location, but at the end of the box. Between these two should be a midpoint. 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4. At the bottom of the box should be a midpoint. At the middle of this box should be a minimum. Between these two dots, to get from the top of the box to the bottom of the box, we have to cut through the middle. And same on this side. To get from the bottom of the box to get to the top of the box as a cosine, it would have to cut through the middle. And using these 5 dots, connect. That's it. Yes?
Why are we doing, why is it -4?
Minus 4.
Isn't that minimum point -4?
Yes, it is.
I was confused where we got that.
Well, my midpoint is negative 1.5,
Right?
and I go down by another 2.5.
So why? Oh, never mind. Okay, now I see it. Thank you.
Learn.
Why isn't the new negative?
Oh, it is. It's negative. I just erased it. I whited it out because I wanted to show that. Oh, why is it not at 2 pi?
Yeah.
Oh, because there is a shift. I start 1 box to the right, and then I have to count 8 boxes. I have to count 2 pi from there. Yes?
If we do the box method, we need to continue the entire length graph or just fill out 1 box.
Nope, 1 box is fine. The test questions will always say, draw me 1 cycle. So you can draw me this, or if you want to be a little cheeky about it, be like, oh, Mr. Kim, it continues, don't forget. That's fine, because that's sinusoidal. If you show me 1, it repeats again and again and again. That's all it is. Okay? Now, we're running out of time, so you won't be able to see me do more examples. Like, there's another example here. And then if you know your AKDC, you should be able to also go in reverse. Now maybe we can start the next class doing this, but I didn't even get a chance to start 5.4, so I'm going to ask you to do this page, this booklet. Forget the textbook, just finish this booklet for homework. Whether you want to do step by step or if you want to do box method, that's up to you. But finish it off. Check your answers with my sheet online, and that's it. Questions?
So I was just wondering, like, how do you remember whether it like starts like down and up or like up and down? Does it change for cosine and sine?
For sine, if this was my box, I know it would have to have these 3 points because sine always starts at the transverse axis.
Okay.
For cosine, it's going to be up, up, or it could be down, depending on the reflection.
Okay, but it starts above. Okay.
But yeah, because you know that the sine curve originally looks like this, and
Yeah.
cosine is like that.
Okay. And then if it like change, if there's like something to change the direction, then it just goes like opposite. Oh.
Correct. Any other questions? That's a good one. Just to clarify. All right, everyone. In 2 minutes, you'll be done. So we're gonna pack up and dismiss. Please try these last few questions or this entire package as homework.